This is the screencast for section 8.3, example 3, comparing x with x plus sine of x as x approaches infinity. Show that x grows at the same rate as x plus sine of x as x approaches infinity. So if we're looking for the same rate, we want the limit as x approaches infinity of one of the functions over the other one to equal 1, but in this case it equals infinity over infinity. Alright, so let's use L'Hopital's. The limit then as x approaches infinity of 1 over 1 plus cosine of x. Well, cosine of x as x approaches infinity is going to fluctuate between -1 and 1. So it's kind of hard to come up with a conclusion about the denominator here. That is a big question mark. So let's start over. Let's instead make x plus sine of x the binomial in the numerator and x in the denominator, and then just simplify a little bit. Yeah, it's infinity over infinity, but watch this. X over x is 1 plus sine of x over x. Don't we know the limit as x approaches infinity of sine of x over x? Yeah, that's 0. So we have 1 plus 0, which is in fact 1. So since the limit as x approaches infinity of one of the functions over the other one did equal 1, that means y equals x and y equals sine of x grow at the same rate as x approaches infinity. Now try problem number 9. Says show that x squared grows at the same rate as the given function. Alright, well, I have learned my lesson from the other problem. I'm going to put the binomial x squared plus 4x on the top and then the monomial x squared on the denominator. Yes, I could continue to simplify this, but I want to show you something. Back in chapter 2, when you saw this, we knew it would equal infinity over infinity, but what you used to do was then say, okay, take the first term divided by the second term, and that simplifies to be 1. Well, now we have this fancy L'Hopital's rule that we get to use. The limit as x approaches 0 of, the numerator is 2x plus 4, the denominator is 2x. Still infinity over infinity, so we'll take L'Hopital's again. Derivative of the numerator is 2, derivative of the denominator is 2, and now you can see by L'Hopital's rule that that will in fact equal 1. The limit will equal 1. Therefore, y equals x squared grows at the same rate as y equals x squared plus 4x as x approaches infinity.